Physical properties are properties that can be observed and described without changing the makeup of the original substance. We can further classify this into extensive or intensive properties. Extensive physical properties depend on the amount of the example. For example, mass, energy, and volume are all extensive physical properties. Intensive physical properties are independent of amount. They do not rely on how much of a sample you have. For example, color and melting point, those are all intensive properties. Take a moment to pause this video and identify whether the following physical properties are extensive or intensive. Mass is extensive because it depends on amount. Density and color are both intensive. Note that density is an intensive physical property. No matter how much of a sample you have, its density will remain the same. Density is a ratio between mass over volume, so no matter how much water you have, its mass and volume ratio will be proportional to one another. Water will always have a density of 1 gram per milliliter. Therefore, we consider density as an intensive property. Energy is extensive. Melting point is intensive. Volume is extensive, and boiling point and smell are both intensive properties that do not depend on amount. Chemical properties are properties that can be observed only when the substance changes its makeup. They are properties that describe the matter's reactivity and involve a change in the identity of a substance. Matter can undergo physical and chemical changes. Physical changes are changes to the substance that do not change its original makeup. For example, water is still H2O, 2 molecules of hydrogen and 1 molecule of oxygen, regardless if it is in the solid, liquid, or gaseous state. Chemical changes are changes to the substance that do change its original makeup. Therefore, the properties of the product are going to be different than the properties of the initial reactants. Phase changes are a type of physical change that requires no change in the original makeup or properties of the substance. Melting is going from the solid state to the liquid state. Freezing is going from the liquid to the solid state. Vaporizing or evaporation is from the liquid to the gaseous state, and condensing is from the gaseous to the liquid state. We call sublimation as going from the solid state to the gaseous state, and deposition is going from the gaseous state to the solid state. There are different indicators that a chemical change has occurred. Remember, chemical change is going to change the properties and the makeup of the original substance. Indicators of a chemical change are the production of bubbles, precipitation, which is also called the formation of a solid, the presence of heat or cold, light released, and a color change. So matter can be classified under different categories: pure substances and then mixtures. Matter that has a uniform and definite composition is called a substance. Pure substances can be elements or compounds. Pure substances only contain one type of matter and has a uniform and definite composition. Aluminum and copper are examples of pure substances. All samples of pure substances have the same characteristic properties. Elements are the simplest form of matter that has a unique set of properties. These cannot be separated into simpler substances by chemical means. All matter is composed of elements, and these are represented by a symbol that is listed on the periodic table. Compounds are also pure substances, but they're made up of 2 or more different elements that are chemically bound together. Elements lose their original properties to form a new substance with its own characteristic properties. For example, sugar is a sweet-tasting white solid, but it's made up of elements carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen have very different properties. For example, carbon is a tasteless black solid. Let's look at another example. Sodium is a soft gray metal, and chlorine is a pale yellow poisonous gas. However, together, sodium chloride is table salt, which we know as a white grainy solid. Since compounds are made up of more than one element, they can be broken down or decomposed into simpler compounds or elements by a chemical change. Heating is one of the processes that we can use to break down compounds into simpler substances. Note this is sugar in a pan, and as we heat it up, you can see that its original carbon, the black, tasteless carbon, is seen. Matter can also be classified as mixtures. Mixtures are a physical blend of 2 or more substances. Each substance retains its own identity and properties, and these properties are going to vary as well as their composition. Mixtures can be separated by physical properties. There are 2 different types of mixtures: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are mixtures in which the composition is uniform throughout. These have the same properties throughout the entire substance and are normally made up of a single phase. Therefore, we cannot differentiate their parts. For example, if we put salt in water, the salt will dissolve and all of it will be in a single phase. This is also known as a solution. Olive oil is an example of a homogeneous solution. Can you think of other homogeneous mixtures or solutions? Sugar water, air, alloys as well. Alloys are a mixture of metals, so a lot of times we have a mixture of metals in fake jewelry. Heterogeneous mixtures are mixtures in which the composition is not uniform throughout, or not evenly distributed. So these often consist of 2 or more phases. For example, if we have sand and water, the sand is going to be in the solid phase and the water is going to be in the liquid phase. These are usually more easy to separate. An example of heterogeneous mixtures include salad, oil and water, or muddy water. Reminder, mixtures are a physical blend of 2 or more substances. Therefore, we can use their differences in physical properties in order to separate mixtures. So mixtures can be separated by undergoing physical changes that do not change the original makeup of those substances. Let's think about this. Why aren't there coffee grounds in a cup of coffee? A process of filtration is able to separate solids from the liquids. Therefore, the liquid brewed in the coffee passes through the paper filter, but the solid coffee grounds cannot pass through the filter. How could we separate a mixture of salt water? We can use a process called evaporation. So we identified salt water as a homogeneous mixture or solution. Therefore, if we put it over heat, the water will evaporate, leaving the solid salt behind. Notice, neither the properties or composition of the salt or the water are changed. Chromatography is another method that we can use to separate components of a mixture. There are several different types of chromatography, including paper chromatography, column chromatography, affinity chromatography, but all you need to know is it's another form of separating physical mixtures. Distillation can also be used in order to separate homogeneous mixtures and solutions. For example, let's say I have liquid A and liquid B that are mixed together. If I put this over a flame, they will have different boiling points. Let's say liquid B has a lower boiling point, meaning it will evaporate faster. So if I increase the heat of my flame, my liquid B is going to evaporate, separating itself from liquid A. And then I can condense my liquid B and put it down back into a liquid in a separate container. Then I have successfully separated liquid A from liquid B. Notice, if the composition of a material is fixed and uniform, we call the material a substance. If the composition of the material varies and has different properties, then the material is a mixture.